Hello, and thank you for joining today's webinar. This is our first joint webinar with Corelight and cPacket, and we're really excited to overview our joint NDR solution today. My name is Trey Moczygemba. I am the Cloud Product Manager here at cPacket, and along with me is Todd Morneau. Todd, do you want to introduce yourself?
Sure. Hi, I'm Todd Morneau from Corelight, also in product management and also responsible for our cloud solutions.
Awesome. Well, thank you, Todd. And again, we're really excited today to go through some of the content we've prepared. Hopefully you all are as well. And just a quick reminder that we do have a live Q&A at the end of the show. So feel free to put in your questions on the LinkedIn post or elsewhere, and we will be sure to address those. And with that being said, let's go ahead and just jump right into the content.
Sure.
I will turn it over to Todd.
Awesome. Thank you so much. Appreciate it. So what we're going to go over today is how Corelight has adapted its NDR solution to cloud environments, and furthermore, how cPacket enables you to take advantage of those solutions inside of your cloud environments. And one of the biggest things we do, and one of the first things I always do when we're talking to our customers, is to try to understand their pain points and what we can do to help them in their cloud security journey. And there's kind of four main themes that we touch upon here that we've heard from many of our cloud customers. And one of them is always around, hey, you do network security, but what about VPC flow logs? Well, VPC flow logs are great. They offer you a very wide picture of your cloud environment, but they do lack depth. They're very shallow. Effectively, all you get is a 5-tuple of what's happening. And this, while useful for doing simple IP matching for things like C2 command and control centers, leaves people who are looking for higher level attacks or investigations or threat hunting a little bit without somewhere to go. So we like to bring in a little bit more enrichment, a little more depth, and all the kind of contextual data you're going to need to do a serious incident response or threat hunt. Another thing that comes up a lot for us is customers use us in on-premise environments to augment and supplement their EDR solutions. We have partnered with major EDR vendors, and we are partnering with all sorts of different cloud EDR vendors, CNAPP providers, CWPP, all the likes, to make sure that we can work with them to provide you a complete picture of your security solution. One thing I always laugh about is I've been doing cloud security for a long time now. And I always ask people, hey, raise your hand if you think you have 100% coverage for all your hosts. And inevitably, I've never found a single customer that has it. With cloud environments being as ephemeral as they are, constantly changing, everything shifting around, it's a near impossible task to say, hey, I have an agent on every box I need to see. And that's where we come into the picture and where we can help out. The network layer is always there. And the network layer is something that's a bit immutable, so we can see everything traversing across your network when deployed correctly. One thing to point out across different clouds is something that some people aren't aware of is that cloud telemetry is not consistent across the cloud service providers. We work with many different customers that have multi-cloud environments, and they will always complain to us that, hey, VPC flow logs aren't the same across cloud providers. And that's absolutely correct. There's different formats, there's different time sample rates. There's some cloud service providers that only sample data, so you never get the full picture of what's going on at the network layer inside your cloud. And that's something that we at Corelight, combined with cPacket, can help out with. And lastly, one thing that is often obvious to some folks, but often not said, is that as you scale out a multi-cloud environment, you can see there's tables available online that map all the cloud service providers' tools across, and you can say at a high level, they are all the same. They're very similar in what they do and what they try to accomplish and what security they bring to the table. But what they don't say is you have to have expertise and learning across each and every tool. So if you scale that up, and some of our customers are in 4 clouds, across 4 clouds, 4 tool sets, that's a lot of horsepower and a lot of effort needed to be able to do a proper cloud security at the network layer across those environments. So what can Corelight do, and what are we trying to accomplish here? Well, as I built out the slide rapidly, what I want to show you is that we have done a lot to make sure that across your multi-cloud environment, you get a similar experience. On-premise, hybrid, multi-cloud, We want to be a tool that is applicable to all. So that's what we've spent a lot of time and effort creating. And I'll go into a few details of that in the next slide. But the real name of the game is cloud attacks happen, on-premise attacks happen. Oftentimes they're very similar, but how they're carried out in the different environments is different. And that's where there's always a little bit of a gotcha in there. That's what we're trying to help out with. And that's what we're trying to enable our customers to get better at. We want to be able to provide you the rich context, data, and enriched data sets and logs to be able to discover kind of higher level attacks and see how they're being played out and be able to stop and disrupt those attacks before you're compromised. We want to make sure that our tool is applicable across all your environments. Again, on-premise, hybrid, multi-cloud. We don't want you to have to relearn, retrain, or upskill any more people than is necessary. And how do we do that? Well, here's 3 examples of how we have adapted our solution to cloud environments. Top left, you see rich visibility with autocorrelation of data. What does that really mean? If you look at it, and I apologize because I know it's a bit of an eye chart, but I'll tell you what's in there. There's a connection log. So you get the 5 tuple, you get additional data that Corelight brings to the table, but those 2 green boxes are where the magic happens. If you've ever tried to do an investigation or a threat hunt based on an IP address and a timestamp in a cloud environment, it is very hard. It is very difficult to go back and map what box had that IP address when. And the reasons for that is in the cloud, natting is a big tool that everyone uses, network address translation. There's orchestration tools, there's auto scale groups. And what they always end up doing is recycling and changing the IP addresses that are available. So what you can't do is figure out, hey, directly looking at the VPC flow log, which box had that? What was going on there? So we embed that data for you. And we say, here's your instance ID, here's your instance name, VPC ID, org ID, et cetera, et cetera. So you don't have to go through and look at all of these different tools or logs to try and figure out what box had an IP address at a certain timestamp. And if you could extend that a little bit from the network layer, we also realized in public cloud environments, we can detect what services they're contacting. So on the right is an AWS example. And you can see that you're talking to S3, you're talking to Kinesis, you're talking to Firehose, all the different services available. And what does that really enable? It's good to know where your traffic's going, but what can you do with that data? And that's where the real magic happens down below. As I mentioned before, attacks across different environments are often played out in similar patterns, but they're done and executed differently in the cloud. And cloud-specific execution is what we're trying to look at now. So if you say service enumeration, what is service enumeration? Oftentimes when a host gets compromised, what a malicious party will do is try to understand what the permissions and bounds of that host that they've compromised are. They want to understand what lateral movement they can do, what services they can touch, what malicious things can they do with control of that box. And from the network layer, if you can identify all the services you talk to, that's pretty obvious. You can see, hey, all of a sudden this host is talking and trying to ping 25 different services that it's never tried to contact before. That's a behavior that you can see directly from the network layer that is very powerful. Another thing you can see, data exfiltration. Data exfiltration tends to have common patterns where people aggregate the data they want to exfiltrate and then ship it off. Inside of a cloud environment, we'll take an S3 example. You can see large amounts of data going to a singular S3 bucket if you have the service identified and you have a call log that shows where everything is going. So by taking those 2 things, you can hopefully detect, hey, data is being staged in an S3 bucket, and we should stop that, and we should take a look at that before you're compromised. These are just 2 examples of what you can do from the network layer with a well-implemented, well-deployed set of tools like Corelight and cPacket that can help you build your security posture inside of a cloud environment. And here's just a quick case study I wanted to run through. We have a lot of different customers, and this particular customer is a large mortgage vendor, and they have estates across on-prem, AWS, Azure, and they have a big problem with visibility. They don't want to have to have expertise in security teams for each individual environment. What they wanted was a tool that could get network visibility across all three environments. And that's what we brought to the table. We brought to them a network detection and remediation solution that provided them with complete visibility across all three environments. We normalized the data across the different environments so that when they went to go utilize it downstream in their SOC, it wasn't like trying to learn three different tools. It was a singular tool, bringing them all the data from their three environments. And what were the results? The results were with our extended visibility of data from the network layer, they could spot things like file extension changes, which indicated ransomware attacks. They could spot and understand where their network was not fully implemented with encrypted solutions. They used our tool for a wide variety of different purposes, but they all tied back to the network visibility that we gave them. And how does that work? Well, this is a super high level diagram that I'm sure everyone's seen before. And what we do at Corelight is process network data. In the cloud, it is not as straightforward as you think to get that network data to us. There are different levels of maturity across Google, AWS, and Azure, where their network tapping and mirroring capabilities are not even. And that's where a great partner like cPacket comes into play. And they really can help you implement and extend your NDR visibility across your cloud environments. And with that, I'm going to hand off to Trey to go over what cPacket can bring to the table.
Absolutely. Thank you for that overview, Todd, and definitely some really interesting stuff that Corelight's doing in partnership with cPacket. Just a quick reminder, we do have the Q&A, so feel free to throw in your questions that we will get to at the end of our session today. But let's go ahead and jump right into our next slide. So when we start talking about cPacket, for those not familiar with the company cPacket, we value packet acquisition from data centers to cloud environments. But we always kind of start the conversation with our packet broker layer, which is where we'll spend the majority of our focus today, especially in relation to the Corelight solution. So our packet broker is able to replicate the same packet up to 10 downstream tool sets. And one of those downstream tool sets, as you see on the top left there, could be Corelight. You could also have NPM, APM tools, and also analytics and manageability solutions that you're replicating packets to. So unlike the native traffic mirroring services, which I'll talk about in a little bit more detail about later, we can actually replicate the same packet up to 10 times, unlike the native solutions, which can only make one copy of the same packet. But the other thing about our solution that's a little bit different from other competitors in this space is that we are totally agentless. So we don't even produce an agent as cPacket. We don't have anyone working on agents. Our entire solution is based around the premise that our cloud and virtual solutions are acquiring traffic totally without the use of agents, which is a really important benefit that I'll get into here in a little more detail on the coming slides. The other thing is we can provide the most reliable data to tools. So unlike traffic mirroring, another sort of pitfall or a caveat with traffic mirroring is that it is considered a best effort service, at least in terms of AWS and GCP today. So what that means is during periods of network congestion, you actually may not get all of the packets replicated to a downstream tool set because production traffic will always take precedent in the scenario where there is network congestion at the CSP level. So by implementing the cPacket CVV solution, you actually get more reliable data to your tool sets, and you avoid those blind spots in visibility, which is really important, especially in the context of security tools. Todd can answer for me, but I like to think that security vendors would absolutely value the fact that we provide the most transparent and the most packets as opposed to some of the competing services. So that's another unique thing that we bring to the table with our joint cPacket Corelight solution. And again, the other thing is we can provide visibility into north-south and to east-west traffic flows, which is also something that Corelight fully supports. So this isn't limited to just north-south or just east-west. In conjunction with some really cool CSP technologies, which I'll get into in a little bit more detail, we are able to support both flows so that Corelight and other downstream tool sets are able to benefit from the visibility into east-west and north-south traffic flows. And as Todd said, you can see there on the top right, we support the same major CSP vendors, Azure, AWS, and Google Cloud. So there's a lot of parity and cohesiveness with what we're doing at cPacket and what Corelight is also doing as well. So with that being said, I'll ask Todd to move to the next slide. So again, I talked a little bit about an agentless solution and why that's so important, right? People already have opinions on agents. Some people may be pro-agent based, other people maybe not so much. But I like to talk about some of the pros and cons. So really, if you think about an agent-based solution, what you're doing is you're deploying an overlay network. And that overlay network requires maintenance, it requires patching, it requires agents to be deployed on literally every node. Here I have pictured some Windows VMs and some Linux VMs, but you go down the list of the different software solutions that are present in enterprise solutions, and it can obviously get very cumbersome, right? So you're talking hundreds to thousands to tens of thousands of nodes that you're having to install agents on. So again, that's inherently a big responsibility, and it becomes complex to deploy and maintain those agent-based solutions, which again are more of an overlay network on your production infrastructure. The other thing to consider with agents is they do degrade system performance. So because it's running on the system itself, inherently there is going to be some impact to not only the CPU performance, but also memory, and even more importantly, in cloud workloads, the network throughput, or impact on the NIC itself, due to the fact that you have these in and out transactions from an agent perspective. Agents are also prone to blind spots. I'll get into a little bit more detail about how cPacket enables a more robust packet visibility solution. And inherently, the most important thing when it comes to agents is that it is a security vulnerability inherently by having agents deployed in your network. It's another piece of software you have to deploy on all your nodes, another potential impact point that a bad actor can come in and try to infiltrate. So essentially, there's not a lot of pros that I can come up with in terms of an agent-based solution. Again, pick your own poison, but that's certainly my perspective as the C Cloud product manager. On the right-hand side, what we do in terms of how we are able to acquire traffic agentlessly, in the most simple of terms, is that our Azure and AWS solutions support a couple of different technologies, but most importantly, what I'll spend the time on today is through the use of routing changes. So in Azure, this could be user-defined routes in terms of you point the next hop to be a CVV virtual packet broker appliance, and then we replicate that packet and send the traffic onto its original destination. And we can do the same type of thing in AWS with the use of an AWS gateway load balancer and route table manipulation. But essentially, by intercepting the traffic and essentially serving as a bump in the wire, or as I like to say, a bump in the cloud, we can acquire the traffic agentlessly, and therefore it's a much cleaner solution, which you're only having to do one software upgrade every 3 to 6 months, depending on your security policies, as opposed to constant patching on your agents, which is something that actually happens quite frequently. And then you see with the green dots pointing down to the Corelight software sensor in this example, we're able to do all of this kind of out-of-band replication to Corelight. So again, this isn't impacting the production workflow. It's simply that we're replicating a VXLAN packet, VXLAN encapsulated packet down to a Corelight toolset. So inherently, it's more secure by design. It doesn't have the vulnerabilities or the vulnerability, concerns that you might have with an agent solution. It's superior in terms of acquiring more traffic, which I'll get into in a little bit more detail in just a moment. Again, no overlay network to have to maintain. You're not impacting system performance outside of adding a minuscule amount of latency in the traffic path, and you avoid the downtime that is required with all these constant agent updates, and also user impact experiences. I know I personally have to install updates pretty regularly on some of the agents that run on my machine for security purposes and otherwise, and certainly to not have to worry about those types of solutions in the day in, day out scenario on an enterprise network is important. So just a few benefits of why I feel the agentless solution is certainly a bit more elegant than some agent-based solutions which our competitors are privy to. So with that being said, I'll ask Todd to proceed to the next slide here. Thank you, sir. So again, I talked a little bit about the inline routing on the last slide, but we also support a mode where we can support traffic mirroring target. We can serve as essentially as a traffic mirroring target for an AWS traffic mirroring session. So there's some pros and cons here. And what I would say to this is there's really no right or wrong. It's more about what works better for your enterprise topology What I've learned in the cloud product manager for a couple of years at cPacket is there's really no two enterprise scenarios which are the same. There's always caveats and little edge cases that work their way in. So really, it's all about understanding what works best for your solution. If you require on-demand visibility as opposed to continuous visibility, as an example, and all of those types of things. But in terms of inline routing, again, I already touched on some of the benefits there. It's more complete visibility. We're able to acquire more packets because we're not susceptible to the blind spots with traffic mirroring services, and also easier management. And in terms of the cons, inline routing changes may be disruptive. So certainly in terms of getting the setup stood up for the first time, there are some things you have to consider, and also some routes you may have to manipulate to get everything connected. But once it's up and running, it's inherently easier to maintain than an agent-based solution. In terms of traffic mirroring targets, though, it is an out-of-band service. So you're not having to worry about some of the inline disruption, potentially when you do software upgrades or when you're doing the initial deployment. But again, traffic mirroring is prone to those blind spots and gaps in visibility, and it's more difficult to manage and scale. Not to mention cost. Traffic mirroring in AWS, because Azure today does not have a packet replication solution that's in a GA form, but AWS today, it's not only expensive because you have to enable it for each instance that you want to turn it on, but also it's not supported by all VM types. So then you have to kind of do a matrix exercise of, okay, what EC2 instances do I have deployed in my network? Do those VMs support traffic mirroring natively? Are there other considerations, let's transit gateways, or how do I get that traffic between VPCs and potentially even just subnets, right? Depending on the routing rules and the configuration. So there's a lot of different considerations, but certainly scaling out traffic mirroring can present challenges. And that's why I'll spend a little bit more time talking about some of our inline solutions today. On the bottom there, you kind of see some of the key technologies that we integrate with on the Azure and AWS platforms. So we support Gateway Load Balancer in both Azure and AWS, and I'll talk a little bit about that in some topology examples that are following. And then we also support Azure Load Balancer, Azure Virtual Machine Scale Sets, known as VMSSs or VMSS. So that's really important, and I'll talk about why. And then also we support user-defined routes, which is, again, how we are manipulating the routes to point to our virtual packet brokers as the next hop in the data path. And then on the AWS side, again, we do support the Gateway Load Balancer. We also support network load balancers, depending on what you already have in your production infrastructure. We also support auto-scaling groups for high availability and resiliency. And again, we do support VPC traffic mirroring. So even if you use traffic mirroring, we can serve as your centralized hub for monitoring, and we can help distribute those packets to any number of downstream tool sets, again, overcoming that limitation with AWS, where you're only able to replicate a single packet to a single destination. So let's actually go ahead and look at what some of these topologies look like. And I will fully admit these are pretty elementary examples, but hopefully you at least get the spirit of what our tool is doing in terms of intercepting some of these traffic flows. So the first one I'm going to start off with, which I always start off with this because this is really the most dynamic solution in terms of what AWS Gateway Load Balancer supports today. It's able to support north-south and east-west traffic through the AWS Gateway Load Balancer. Azure actually only supports the north-south flows right now for their Gateway Load Balancer, and I'll talk a little bit about that as well. But this is the good example because it's starting with what are all the things that we can do in terms of utilizing the native technology in the Gateway Load Balancer. So what you see on the left-hand side are a couple of consumer VPCs, and you have these EC2 workloads that are pointed towards an endpoint, and this is known as Gateway Load Balancer endpoint. So what this does is it actually automatically establishes a route to a Gateway Load Balancer through the use of AWS Private Link, and it makes it really easy in terms of configuration. You don't have to worry about transit gateways. You eliminate a lot of the how do you get the packets from X to Z, right? So you eliminate sort of that equation or that math that you have to do to figure out how to get traffic from A to B. And we do all of this through the use of Gateway Load Balancer endpoints, which are deployed in VPCs or subnets. So essentially you set the traffic to be the next hop to be that Gateway Load Balancer endpoint. And then you see the 1, 2, 3, 4, 5 there in terms of what's happening with the traffic. So 1, it goes to the Gateway Load Balancer. Number 2, it goes directly to our CVV instances to make a copy of that packet. 3, it goes back to the Gateway Load Balancer, where it then rides Private Link again back to the Gateway Load Balancer endpoint, and then the traffic is sent on to its original destination. In this case, this is a north-south scenario, so it would be going towards the internet. So in this case, we're able to monitor all of those packets and replicate the exact packet flows from your EC2 instances to our brokers out to the internet, all through the use of this gateway load balancer endpoint technology. And then on the right-hand side, this is kind of known as a monitoring VPC, where you may have cPacket and Corelight virtual appliances deployed simultaneously or side by side. So in this case, you can see that we're able to replicate the packets to Corelight, a CStore V, which is our packet capture and analytics appliance, and then we have our cClear V, which is there from a manageability and analytics perspective. So again, all of this is enabled through the gateway load balancer endpoint. This is just a north-south scenario, but you can certainly imagine seeing the traffic flow from the top VPC on the left there to the bottom VPC, but also being able to replicate those same packet flows through the use of the gateway load balancer and gateway load balancer endpoints. So this is a really elegant solution that we support today in AWS, and we'd be more than happy to discuss this with anyone who's interested. Let's go ahead and move forward to our next example in AWS. So this is a traffic mirroring solution. So this is a little bit simpler, frankly, where you're relying on traffic mirroring to get packets to a load balancer, which fronts our CVV virtual appliances. So same concept, you turn a traffic mirroring session on each EC2 instance. Those traffic mirroring sessions then target our network load balancer, and this is all an out-of-band communication flow. So there's no back and forth in terms of communication back and forth between the VPCs. This is simply an out-of-band packet replication and VXLAN to a network load balancer, which is then forwarded onto our CVV virtual appliances. And then you can see on the bottom there, same situation where we're able to replicate the packets to Corelight, CStore, and any other tools, again, up to 10 tool sets. What you'll also notice is that we do have those CVV instances. You'll notice there's 3 of them, and then it's also deployed in an AWS auto-scaling group. So we typically recommend deploying at least 3 of our virtual packet broker instances for high availability and resiliency. And then we're closely integrated with AWS auto-scaling groups, so we can seamlessly scale out and scale in depending on variable traffic workloads. If a particular instance has an issue, that'll automatically be detected through load balancer health checks, and then we can automatically spin up a new instance before there's any impact to any production traffic workflows. So we've done a lot of work to really closely integrate with the native CSP technologies to create a high availability, highly resilient solution that can deliver packets to Corelight reliably, whether you're an inline or in a traffic mirroring scenario. So that's a high-level overview of our AWS solution. Again, definitely the devil is in the details with these topologies, but always happy to discuss more. And again, feel free to throw any questions on any of these AWS examples in the chat, so we can cover those at the live Q&A. All right, so now we're moving on to Azure. So in Azure, because they do not have a virtual tap capability in a general availability state today, the only way that we can acquire packets in Azure without the use of agents is through the use of inline routing. So this is very similar to what we looked at for the AWS Gateway Load Balancer in terms of an inline scenario. This is a unique example because this is actually a north-south and east-west traffic acquisition flow. So you'll see on the bottom there, we have a gateway subnet and a firewall. So traffic coming in from the internet, presumably. And then on the left side, we have 3 Azure VMs. And all of those are fronting a load balancer. And that load balancer fronts our CVV instances. So all of that traffic can go through a single load balancer, enabling us to see both east-west and north-south traffic in Azure, which is really important. And this is all, again, enabled through a single monitoring subnet or potentially a VNet, depending on how you architect it. But this is all, closely integrated with the Azure native services to enable a seamless delivery of packets to any number of downstream tool sets. So on the very right side, you'll see the tool subnet, and you'll see that we're doing all of these VXLAN packet tunnels to these various tools. So we have 3 Corelight soft sensors deployed in this scenario, perhaps an IDS tool, and perhaps an NPM tool. Again, up to 10 tool sets in terms of how many packets we can replicate to. So this is a really cool example. You can imagine segmenting this in many different ways, but it shows the power of, again, being able to capture both north-south and east-west traffic in Azure without the use of agents, which is really important for our customers. And the last example, I did mention Azure actually does have a gateway load balancer, and there are some really cool things you can do with it. We have some really exciting implementations with some large production customers today where they're utilizing gateway load balancer chaining, which is another really cool technology in Azure. We're even able to get traffic out of Kubernetes workloads in that example. So definitely some really cool stuff happening with the gateway load balancer on each CSP platform, each with some of their own pros and cons for sure. In the case of Azure, we're only able to use north-south traffic acquisition today. I believe gateway load balancer for Azure is going to support east-west at some point next year, but as of today, it is just north-south. But this is very similar to what we looked at for AWS, right? The difference is, we're just using UDRs here as opposed to using a gateway load balancer endpoint, but traffic can be routed directly to a gateway load balancer where traffic is then takes the 1, 2, 3, 4, 5 hop back out to the internet, and we're able to acquire all of those packets very seamlessly. And again, you'll see that Corelight's on the bottom. We have our C-Store packet capture and analytics platform and the same management with cClearV. In Azure, we also do support virtual machine scale sets. So this is very similar to AWS auto scaling groups, at least conceptually. There's some really cool things we can do with virtual machine scale sets in Azure, such as rolling upgrades. Basically, if you have a new software upgrade, for example, you can deploy a new CVV with a new software patch, and then gracefully those machines will start spinning down and spinning up with new VMs, but all while avoiding any flow or interruption in traffic flow. So it's really seamless. It's actually a pretty cool technology that we're able to do, just leveraging the Azure native VMSS capabilities. And we have all of this available in Terraform as well. So I know that may be one of the questions that folks have is how do you deploy? We have excellent Terraform examples. We're also in very close collaboration with Corelight on those examples. And it really enables us to have, ultimately a single GitHub repository where we're able to share all of these things very easily with our customers. And ultimately speaks to the joint solution and the collaboration that we've enabled between cPacket and Corelight. So definitely some really exciting things happening in terms of deployment and also our capabilities using Gateway Load Balancer in conjunction with Azure, AWS, and Corelight. And that brings us to our Q&A. So let's go ahead and get started with the Q&A and see what great questions folks have.
Great.
All right, let's go ahead and tee up the first question. Give our webinar admin a moment here. Okay, so first question, here we go. How do Corelight and cPacket make initial deployment easier? With multiple vendors, it's sometimes hard to deploy multiple solutions in isolation. So yeah, I'll take a stab at that, and then I'll have Todd add some color at the end. But I spoke to it at the very end of the presentation there in terms of us enabling Terraform, and that being one mechanism to make deployment easier for our customers. I know on the cPacket side, we also support some other technologies that are particularly helpful, especially when it comes to getting POC stood up and things like that. With Azure Bicep templates, we also have some AWS CloudFormation templates. So really, we try to meet customers where they are in terms of what their deployment, philosophy is. Some folks actually just prefer to do everything point and click through the UI, which is not my personal favorite, being on some of those calls. But ultimately, it's where our customers are. And again, Terraform is one infrastructure as code solution that does state really well. It helps maintain and manage changes very well. And again, when we have some of the close collaboration that we do with Corelight as one of our partners, it makes it very easy to sort of version control and ensure that there's some level of testing and QA ahead of when our customers are actually putting that into their production infrastructures. Todd, anything to add to that?
Yeah, we are similar to you folks where we've leaned into infrastructure as code. Most of our customers that have cloud deployments use Terraform right now. It's kind of becoming the de facto infrastructure as code leader. That being said, we have open sourced everything. So we have a GitHub repo that is publicly available. We have tons of modules in there for AWS, Azure, GCP. Feel free to go in there, use them as you wish. Be aware that they are not meant to be exactly copy and paste because we can't know all your environment variables. So just they're meant to be most of the way templates, and then you can customize to your liking.
Yeah, exactly. And I use the term examples. Todd uses the term templates, but essentially that's what it is. It's a very modular way to sort of insert these Terraform scripts into your infrastructure, and then you can kind of tweak them depending on particular environment requirements. But absolutely well said.
Cool.
All right, let's see the next question here. What do you recommend for auto scaling of your offerings in cloud environments? Todd, you want to start with that one?
Sure. Yeah. So our sensors are designed to be auto-scalable across any cloud environment. We recommend auto-scaling in AWS, scale sets in Azure, and MIGs inside of GCP. Our Terraform modules do go that way as well. Effectively, what we recommend is to put our sensors behind a load balancer, and it just doles out to wherever we need to be, and then we scale horizontally.
Yeah, and on the cPacket side, same thing. We support scale sets in Azure and auto scaling groups in AWS. We scale from the brokering perspective. We actually scale based on network throughput, which is something a little bit unique. A lot of scaling obviously happens based on CPU and or memory, which I think Corelight does the scaling based on CPU. On the cPacket side, we're actually we're scaling regularly, or in terms of a scale out or scale in scenario. It would typically be based on network throughput and just ensuring that all the traffic coming into our various CVV instances, can scale dynamically based on the NIC on the machines themselves, and then also based on the variable traffic patterns that customers may be experiencing in their environments. So yeah, definitely.
Yeah, just one more point on that. You're absolutely right. We do scale on CPU. Due to the nature of what we're doing, we are inspecting packets as they come along, whether they're encapsulated, what formats they're in, how big the packet sizes are in, all change how much CPU it will take to process each packet. So we have to go by CPU instead of actual bandwidth. So it's just a subtle difference for what we're doing between the two use cases.
Absolutely. All right, let's see. Third question here. Why would you need a packet broker in AWS when AWS offers traffic mirroring natively? So I think that question is for me. So I did speak on it a little bit, and that's a question that we get, right? I mean, AWS does offer traffic mirroring across a large number of their machines. So why do you need a broker in the cloud? A couple different reasons. I spoke on one of the earlier in the presentation. I spoke on the fact that it's not necessarily supported by all VM types. So there is a bit of a mapping exercise that you need to do there to understand, do all of the VMs in my AWS deployment actually support traffic mirroring as a service? Obviously, so that's something you can handle in terms of migrations and eventually having more modern EC2 instances, but certainly a consideration for customers. The other big limitation, or one of the other big limitations, is the fact that you are limited to a single copy of a single packet. So you could do some really high level stuff with AWS traffic mirroring and GCP services, such as saying, okay, for SSL traffic, pass it to this target, and for HTTPS traffic or whatever, pass it to a different target in terms of segmenting the traffic. But you can't actually copy a single copy, or take a single copy of a packet and replicate it to multiple downstream destinations. So that's one of the definite big value props that we bring to the table in terms of a packet broker solution, is actual replication to multiple downstream targets with additional logic, with additional advanced filtering, and really, again, centralizing your point of replication as opposed to it being distributed across your entire AWS footprint. Cost is also another thing that customers come to us often about, and we have some cost characterization examples that may be useful or helpful for those interested. But again, traffic mirroring is a per instance service. So you have to turn it on in every single instance. It's kind of ironic, even if you stop an instance and it's not doing anything, if you have the traffic mirroring session still associated to that instance, you're actually still getting billed for the traffic mirroring session, even though AWS frankly knows that it's not doing anything because the associated instance is stopped or turned off. So again, it's a bit of a cost exercise, or they certainly don't make it simple to understand or project these types of costs. But you could certainly imagine in a distributed deployment with hundreds to thousands of traffic mirroring sessions, how those costs can multiply and also become a bit difficult to manage and scale. So those are some of the basic benefits. Again, I think I also spoke on the fact that it's a best effort service. So, you're not necessarily getting all the packets that you would get with an actual inline solution. So those are really the big benefits of why you would choose an actual packet broker or dedicated solution as opposed to the native services.
If I could chime in real quick, actually, a lot of the feedback we get from our customers that have gone to packet broker solutions inside of AWS is because of the limited visibility. As Trey pointed out, it has to be mirrored off of a host. So any traffic that's not mirrored off a host, or if you have hosts that are not in that mirrorable traffic list for the instance type, it's a complete blind spot. And then if you think about instances or traffic that goes outside of hosts, so direct to container services, managed Kubernetes, or to Lambda, that's all blind spots.
That's a really excellent point. All right, I think we have a couple more. Let's see, how do we charge for our products, bandwidth, installation, et cetera? Todd, I'll let you start off, and then I'll finish at the end on the cPacket side.
Yeah, from our perspective, it's very simple. We charge by bandwidth. We actually don't care how many soft sensors or cloud sensors you deploy at all. You can deploy them as much as you want, as much as you care to manage. But we are charging based on bandwidth usage.
Yeah, and we're very, very similar. We're basically charging, our licensing is based on the ingress throughput into our instances, which is ultimately bandwidth. So we actually look at the bytes per day is kind of our philosophy. It's a volume-based licensing scheme. But it's a direct mapping to gigabits per second if you prefer that number. So it's a very black and white sort of figure, but we chose bytes because it's not so dynamic. You can just stay under a certain number of bytes, and it makes it easier to manage. And a unique point that Todd made there, and this is again across both cPacket and Corelight, we don't care about the number of instances you deploy. Again, we care about the throughput or the bandwidth going into the machine. So that actually makes it really flexible, because you can deploy these soft sensors and these packet brokers anywhere you need the visibility. And again, depending on topologies, it may be you may have one set of machines that is doing east-west monitoring, and you may have another set of machines that's doing north-south monitoring, and then you can enable or disable certain services to optimize performance in those use cases. And again, this is really speaks to the uniqueness of the topologies in many of these enterprise deployments. But certainly that flexible nature of it doesn't make it where it just becomes incredibly more expensive, because you want to deploy machines in a different VPC or a different account or a different business unit, however you decide to segment it. So that's definitely a benefit, and that's why it's certainly something that Corelight and I share a similar philosophy on in terms of how we're doing the licensing today. And I think we have one last question, and then we will let you all go for today. Does the inline approach on Azure or AWS add significant latency? So that's a great question, and it does add latency. So full transparency, I'm not saying it doesn't add latency. The latency that we add, though, from the broker perspective, is actually very nominal. In some of the characterization exercises we performed earlier this year, it was something around 30 microseconds of latency, which is really small. So, I mean, it does add latency, and there's a lot of considerations in terms of how you calculate the latency. The number of hops obviously matters, the number of middle boxes that exist in the traffic flow. All of those different hops are going to add latency inherently. But in terms of just the broker and what we're introducing to the equation, it's extremely low. Again, 30 microseconds-ish, give or take. And so ultimately it's we've done a lot of optimization to ensure the fact, we're sensitive to the fact that we're an inline appliance, right? And we understand that customers don't want all of this additional latency. So it's about the minimal latency that we can introduce, just inherently being a Ubuntu box in terms of being a bump in the cloud. So in terms of the traffic mirroring solution that we support, obviously there's not the additional latency there, but there's the issues I already mentioned with traffic mirroring. So not necessarily that an inline solution is required. It is in Azure today, but we can certainly support both modes with AWS and then also GCP. So I think those are our 5 questions for today. Wanted to really thank everyone for spending the time making it to the end of our presentation today. Hopefully this has been informative and educational for those looking for a joint NDR and or cloud brokering solution. So Todd and I just want to thank you all for tuning in today, and hope you have a great rest of your Wednesday here. Thank you.
Thank you. Have a great week. Take care.
Thanks, everyone.